Hello! Today I have a very exciting surprise for you. We're going to do things a little differently. So we're starting a very exciting section, Your Computer Goes Ham Digital. Now some of the concepts in this section are actually easier to explain in a ham shack or a ham radio station than they are to explain in front of a whiteboard. So today I've decided to record our lesson in my ham radio station or my ham shack. And I even have one of my radios turned on for you. So this is my HF radio. This is the kind that you use to talk to people outside the country. So this guy here has talked to Australia, Germany, Russia, South Africa, Alaska, Hawaii, etc., etc. This is the HF radio. And outside the window you can see my 20-foot tall antenna strapped to a fence pole outside. Now this over here, this is my older HF radio that I sometimes use, not much anymore though. And my handheld radios, will probably be your first radio, they sit all the way up here. So over here, this is the power supply for my HF radio. This is what gives this radio power. You plug this into the wall and then this plugs in the radio, and that's how it gets power. And we're going to learn all about that in some later sections. And on the wall over here, you can see all my QSL cards that are taped all over the wall. These cards, every one of them came from a person who I actually talked to on ham radio, and they mailed me one of these postcards or QSL cards in the mail. So these are all the people I talked to. And I have a large collection of cards that I actually still have to send back to people. I've sort of run a little behind. So anyway, let's go ahead and get started with this section. And while we're at it, I'll demonstrate some of the concepts using my ham radio equipment and my actual ham radio station. So let's start by looking at International Morse Code, or CW, which this is actually considered a digital mode on ham radio, believe it or not. And a digital mode on ham radio is basically a mode that you don't use necessarily your voice to communicate. You use something digital, usually with the computer. Oftentimes you type on a keyboard. That's what we mean by digital modes, and usually computers are involved. But the first type of digital mode, which we're going to look at, which you may not have known as a digital mode, is Morse code, or CW, International Morse Code. So there are many ways to send Morse code. Morse code, as you remember, it's made up of beeps, long and short beeps. So there are a few different ways we can send Morse code on ham radio. So this over here, this big black thing, this is called a straight key, and this might look familiar. So this is the easiest way to send Morse code. You simply grab it with your fingers and you start typing away. So that was CQ, CQ, and you remember CQ is what you say when you're trying to get someone to talk to you on ham radio. So the only thing with the straight key, it seems pretty obvious, right? You press this button and you make beeps like that. It's the most obvious way to transmit Morse code. But the problem is that a lot of hams like to transmit Morse code very quickly, as in maybe 30 words per minute. And the problem is it's actually hard to transmit code very quickly just using this sort of straight key. So hams had to come up with another solution, and they came up with the paddle, which is this little red thing here. So the paddle, it works like this. There are two paddles here. That's why we call them paddles. So one paddle is for the short dots. So as I hold this one down, it sends a series of short dots. This one is for the long dots. And if I hold them both at once, they alternate. And in this way, I can sort of send ham radio this way. And you can see how that might work. So this actually allows you to send Morse code very quickly. If you press the paddles in the right order and for the right amount of time, you can send Morse code. Now this paddle actually, it's so complicated that it's connected to what we call a keyer. And the keyer takes the paddle motions, it figures out what paddles you're pressing and at what time, and it converts them into these dots and dashes, into these long and short beeps, these short and long beeps. So my electronic keyer is actually built into my radio. Sometimes you'll actually have a separate box called the keyer, and you can control the speed that the Morse code is sent. That's the nice thing about the keyer. So you can see this is transmitting at a certain speed. You can change the speed at which those dots repeat with the keyer, or on my radio, since my keyer is in my radio. So sometimes you actually have a separate keyer box. The paddle connects to the keyer, and the keyer connects to the radio. And the keyer is what translates the paddle movements into dots and dashes. So there's another way to transmit Morse code too. You can actually use a computer. So I have a computer right here, so give me a second. And if I type in some text here, let me change the pitch, and there you go. That's how you can transmit Morse code using your computer. So it's very cool. That's one reason maybe it's called a digital mode, is because now you can use your computer to send and actually receive Morse code. There are computer programs that can take the Morse code coming in and turn it back into characters. And there are other digital modes as well, and they have names like packet, PSK31 is a common digital mode, MFSK is another digital mode. There are actually many different digital modes out there. So on your technician class test, you might get questions that ask about digital modes. And the answer D, which is all of these choices will correct, that will always be the correct answer for questions that ask about which modes are digital modes. All of the answers will be correct because so many different types of digital modes exist. And they're always being created. Hams are still creating new ones. Just this month or last month, in fact, a new mode came out called FT8. And it's actually brand new. I'm going to try it for the first time myself, maybe this weekend if I find the time. So those are some digital modes. Sometimes you can also send text messages over ham radio using these digital modes. And these aren't real text messages. It's sort of ham radio's versions of text messaging. So these other types, like Morse code, obviously, it's not really a text message. You're not leaving a message on someone's phone for them to read later. They have to be there to be able to hear your message as you're sending it. But you can send sort of text messages over ham radio. And if you do this, we need what hams call a TNC, which stands for Terminal Node Controller. And a TNC basically connects between the ham radio and the computer. So the radio connects into the TNC, and then the TNC connects to the computer. And what the TNC does is it sort of talks to the radio and computer and makes them get along. It translates things back and forth between the two, so you can send these sort of text message things, which are often called packet transmissions. So for other digital modes, though, that are not like the text messaging systems and you're just talking live with the other person, sort of like a Skype contact, we skip the TNC and we just connect the PC right into the radio. We connect the computer right into the radio. So most of the software for ham radio, in case you were wondering, most of it's built for Windows, not so much our Mac or Linux. But if you do happen to have a Mac or maybe even a Linux operating system like Ubuntu, there is some software available for any of those operating systems, and that's enough to get you on the air. Anyway, for digital modes, we connect the computer's sound card, in other words, the headphone and microphone jack, we connect that directly to the radio. So if you think about it, this should make sense. The computer needs to be able to transmit data using the radio. So what it does is, as you're typing text into the keyboard, it converts that data into audio, and it sends it through the microphone port of the radio, and the radio transmits it as audio. So I'm going to go over now to one mode that we call PSK31, and I'm going to transmit some text just so you know what these digital modes often sound like to the radio. Sounds really weird, doesn't it? So that's the PSK31 mode. So as I typed the text, the computer turned it into that audio, and that's the audio that gets sent over ham radio. And that's what it sounds like. So that weird noise actually contains letters and words embedded, believe it or not. It's just sort of in secret computer code, and that gets transmitted on the air through the radio's microphone jack. And then the radio transmits it as audio, and another ham radio somewhere across the world can pick up that audio. And when the audio from the radio goes back into their computer's microphone jack, the computer can take that audio that's being received by the radio and turn it back into the text. So that's how digital modes sort of work. So and then there's what we call packet transmissions, sort of like we talked about yesterday with satellite and packet radios. So packet transmissions actually have a lot of aspects to them. So you need to make sure that the packet transmission or the packet of data gets to the other person correctly without having any errors or something, which can commonly happen on ham radio because of interference and whatnot. So packet transmissions, they often include what we call a checksum. And a checksum is basically something that we use for error correction. You can use the checksum to make sure the receiving station can, based on the checksum, can tell whether the message has been received correctly or not. Sometimes these packet transmissions also contain what we call a header. And the header it just contains the call sign of the station to which the information is being sent, which is automatically very important. And sometimes with packet transmissions, there are also what we call automatic repeat requests in case of an error. So what this is if the receiving station detects that something's wrong with the message it received, that there's an error in the message it received, it will actually ask the transmitting station to repeat its message so that it can copy it correctly. So when the test asks about these things about packet transmissions, all of these choices will be on your test and all of them will be correct. All of the choices will be correct on these kind of test questions because packet transmissions, they do include a lot of different aspects to them. So for example, this is one test question you might run into. Which of the following may be included in packet transmissions? A, a checksum which permits error detection. B, a header which contains the call sign of the station to which the information is being sent. C, automatic repeat request in case of error. Or D, all of these choices are correct. And as we just learned, all of the choices are correct. Choice D is the answer. Now, it turns out there's a special name for asking these, as we talked about in that last answer choice. One answer choice was we talked about asking the sending station to repeat its message because the receiving station didn't quite receive it correctly. It can tell there's an error. And there's a special name for this type of request. It's called an ARQ, an ARQ. An ARQ stands for automatic repeat request. So essentially, an automatic repeat request is when one station says to the other, essentially, say again, I didn't catch that. I didn't hear you quite right. Can you say that again, please? That's essentially what an automatic repeat request is on ham radio. So these errors, the reason why we need these automatic repeat requests and why we have to deal with error correction and everything is because there are errors oftentimes when you're transmitting digital modes on ham radio. Sometimes the person who's sending out the information, he has a weak signal and it's hard to hear him, so the computer can't catch everything. Or other times there's interference. Data signals on ham radio are very sensitive, so even a small change or a little bit of interference can render the whole signal and the whole text unreadable to a computer. And the interesting thing is that sometimes the signal even interferes with itself. Yes, you heard that correctly. Remember in the last lesson with the ionosphere, we sort of learned about how signals can take multiple paths through the ionosphere, and your signal can sort of split up and be received by another station in 3 different ways at once. So this is called multipath, and if there are multipath signals this way, the errors might occur more because all these conflicting signals, they sort of interfere with each other, and the whole signal gets messed up, and that's why we need this sort of error correction. All right, so that's it for now on this section on digital modes. We're going to continue this in another video lecture, but I think that's all for this time. So I hope you enjoyed my little display of my ham shack, and I will see you tomorrow.